Hello everyone, welcome to Quality Icons, Construction Quality, QA/QC and Site Awareness. In today's presentation, we are going to discuss toilet waterproofing systems, including waterproofing methods, material selection, application sequence, critical leakage locations, testing and inspections, and common site failures. Toilet waterproofing is not simply a matter of applying a coating on the floor. It is a complete quality control system starting from surface preparation, followed by bore packing, initial static bonding, leakage rectification, crack and giant treatment, coving, waterproofing, coating, protection, and final bonding. Our objective is simple: prevent leakage before the toilet is handed over. Let's begin. Why toilet waterproofing is required? Why do we need toilet waterproofing? The first objective is to prevent water penetration into the RCC slab. Secondly, it helps protect the concrete and reinforcement from prolonged moisture exposure. And thirdly, it prevents leakage to the apartment or toilet below level. Consider one practical example. A toilet on the 20th floor looks perfectly finished after tiling. But after the apartment is occupied, water starts appearing on the ceiling of the toilet below. Now the problem is no longer just waterproofing. It can involve ceiling damage, painting, electrical services, false ceiling work, and customer complaints. Therefore, waterproofing is preventive quality activity, not merely a finishing activity. Understood? No leakage, long life, peace of mind. Waterproofing system options. So, what is the options are available? There are different waterproofing systems available. Material selection should depend on the application. For toilets and bathrooms or wet areas, polymer modified cementitious system are commonly used because they provide good adhesion to cementitious substrates and are convenient for brush or roller application. Flexible cementitious systems provides additional flexibility, crack bridging capability. Coming to polyurethane or polyurea, like PU, polyurethane or polyurea. These systems provide high flexibility and strong waterproofing performance, but their substrate and application requirements need to be very carefully controlled. Please remember, acrylic systems can be considered for selected applications depending on the product specifications. Sheet or membrane systems are also available for specialized applications like HDP membranes, SBS membranes. SBS means that is the felt with vitamin membranes. The important message is don't select waterproofing material only based on brand or price. Select the system based on the project requirement and manufacturer's technical data. Understood? Material selection criteria. Coming to this slide, before selecting a waterproofing material, the QA/QC team should evaluate several criteria. First, the substrate condition. The substrate must be sound, clean, and free from major defects. Second, is the required crack bridging capability. Third, is adhesion to concrete substrate. We also we need to consider wet area exposure, chemical compatibility application method, and drying or curing time. Another very important consideration is tile adhesive compactability. For example, if a waterproofing material is applied over the slab, but the tile adhesive is not compatible with that system, deboning of tiles can occur later. Finally, always follow the manufacturer's TDS like technical data sheet and approved project methodology. Good material plus poor workmanship still results in poor waterproofing. Please remember, good material plus poor workmanship still results in poor waterproofing. System will fail. Kindly adopt your proper system for the your project requirements. Recommended toilet waterproofing sequence. This is the major important slide. This slide shows the most important part of the entire presentation, the correct sequence procedure for the waterproofing system. First, prepare the surface preparation. Second, complete the bore packing and pipe penetration treatment. See this bore packing and penetration treatment. Third, initial static water ponding test. 75 mm water depth for minimum 48 hours. Fourth, leakage rectifications. If any leakages are found, rectify it and repeat the test. Treat any leakage by grouting or repairing materials. After the substrate confirmed watertight, treat cracks and construction joints. Very important. This is water leakage prone area. Then provide the waterproofing coving, wall floor coving, sorry. Provide 50 by 50 mm coving at junctions or 70 by 70 mm at junctions at our project requirement. After that, apply the waterproofing coating in the specified number of coats. Apply waterproofing coating in the 2 coats or anything, your project requirement based on that. Protect the waterproofing system. That means provide protective screed or plaster as specified. Final ponding test. This is also 72 hours. Final static water ponding test. Finally, tiles work. Proceed for tiles installation after approval. Right sequence is equal to zero leakage. Please see the step 1, step 2, step 3, step 4, 5, 6, 7, 8, 9, 10. These 10 parameters are very important in our routine check, inspection or surveillance at sites. Durable construction, healthy living spaces, low maintenance, happy owners. Okay. Surface preparation. Waterproofing methodology, the first step is the surface preparation. A strong start for a leak-proof finish. Proper surface preparation ensures strong adhesion, long-term durability, and effective waterproofing performance. See these photographs. The waterproofing substrate must be free from dust, dirt, loose materials, mortar dropping, latents, oil, grease, and debris. One example. If cement latency is present on the slab and the waterproofing coating is applied directly over it, the coating may debond, may bond to weak lattice layer instead of the concrete. Later, the coating can peel or debond. A simple QAQC rule is clean, sound, and defect-free substrate. First, waterproofing. Second, first waterproofing. Second, the QC engineer should inspect and approve the prepared surface before allowing the waterproofing contractor to proceed. So remove dust, dirt, loose particles, mortar droppings, latents, oil, grease, debris. If finding any repairs, cracks, honeycomb, surface defects, projections, okay, after cleaning, after repairing. The inspections and approvals by QA/QC engineer before waterproofing application is the mandatory. Okay. Step 2 is bore packing and pipe penetrations. This is also a very critical leakage location. Pipe penetrations are one of the most critical leakage locations in a toilet. We have an RCC slab, a pipe or sleeve, and an angular gap between them. If the gap is not properly sealed, water can find a directly pathway through the slab. The bore should first be cleaned properly and brought to the required SSD condition. Required SSD condition. SSD means surface saturated dry condition. The pipe surface should be suitably roughened and the specified bonding treatment applied. Bottom plugging should then be completed using the approved plugging material. Understood? The angular gap is filled with the specified notching grout. The angular gap is filled with the specified notching grout only. Finally, peripheral coving is provided around the pipe. See this. The objective is to create a continuous watertight transition between the pipe and RCC slab. Pipe, bottom plugging, RCC sleeve, non-shrink grout, polymer modified mortar coving. This is the system. Into next step, initial static water bonding test before waterproofing coating. Why it is critical? Find and fix defects before waterproofing to prevent hidden leaks and future complaints. Prevent leakage, protect structure, save cost, improve durability. What is the checking for? Leakage, dampness, pipe penetrations, construction joints, slab underside. Inspect underside carefully. Now we come to one of the most important QAQC checkpoints, the initial static water bonding test. Importantly, this test is conducted before waterproofing coating. As per the methodology, Presented here, water is maintained at approximately 75 depth for a minimum of 48 hours. During this period, we inspect for leakage and dampness. We should we should pay particular attention to pipe penetration, construction joints, and the slab underside. I will explain one example. Suppose the slab has a small crack that is not visible from the top. During bonding, water finds the crack and appears as a dampness on the ceiling below. Excellent. We have found the defect before covering it. That is exactly why pre-bonding is so important. Understood? Clean, prepare surface, complete bore packing, fill water depth to 75 depth, maintain minimum 48 hours. Inspect underside for leakage and dampness. Record and approve before next step. Already we discussed with the why pre-bonding is critical. I think you can. That main agenda is a hidden RCC defect remains unnoticed. Okay. Water leakage to lower floors, damage to ceilings and walls, dampness, mold and unhealthy environment, high repair cost, time delay, post handover complaints, loss of trust. These are the consequences. Coming to crack and construction joint treatment. After the initial bonding acceptance, cracks and construction joints need to be treated. For cracks, the typical sequence shown here is V groove. Clean, repair, and cure. See V groove cutting and cleaning, repairing. It means repairing with fill with the polymer modified repair mortar or epoxy as per your project requirement. Cure. Cure as per manufacturer's recommendations. The groove must be properly cleaned before filling with the approved repair material. For construction joints, the sequence is V-groove, install injection nozzles, grout and seal. This is the construction joints. The packers fixing, inject suitable PU or epoxy grout or cementitious grout until refusal. Seal the surface with the polymer sealant or coating. Okay. Typical construction joint section. Sealant, groove nozzle, PU epoxy grout, RCC slab. Key points. Treat all cracks and joints before waterproofing. Use compatible materials. Ensure proper surface preparation. Follow manufacturer's TDS. Quality treatment ensures long-term leak protection. Coming to coving at wall floor junction. Wall to floor junction is another important leakage prone location. A sharp 90 degrees internal corner can make continuous coating application difficult and can create stress concentration. Therefore, a suitable polymer modified mortar coving is provided. The project methodology shows here indicates a typical 50 by 50 fillet or coving or 75 by 75 fillet or coving subject to actual site conditions and approved details. The coving provides a smooth transition between floor and wall and helps maintain continuity of the waterproofing layer. Remember, small details can prevent major leakage. What is the advantages? Eliminates sharp internal corner, improves coating continuity, reduce stress concentration, provides smooth waterproofing transition. See the images. This is the recommended size 50 by 50 or 75 by 75, 100 by 100. That is the depending on the project requirement. Okay. Coming to the main step, waterproofing coating application. Do it right today, stay leak free for life. Now the substrate is ready for waterproofing coating. The system shown in the presentation is a typical polymer modified cementitious two-component system. Okay, component A powder, component B polymer liquid. The first requirement is the correct substrate condition. That means SSD or surface saturated dry without standing water. The components must be mixed accordingly to the manufacturer's specified ratio using a suitable slow speed mixer. The material should be homogeneous and free from lumps. The first coat is applied uniformly. The second coat is applied in the perpendicular direction after a specified recoat interval. Apply the second coat is at right angles to the first coat. Required application rate, thickness and curing period must always be checked against the approved product technical data sheets or your methodology. And one important site warning, never add extra water just to make the coating easier to apply. Changing the designed mix can affect performance. Finally, the required thickness, required curing. Good practices is don't add extra water, don't play on wet surface, maintain continuous coating at coves and corners, protect coating from damage before tiling, always follow manufacturer's TDS. Why two direction application is required? Everyone has one doubt. Why two direction application is required? Cross coating is equal to complete protection. The first coat is applied horizontally and the second coat is perpendicular to the first. See the photographs. First coat is applied this direction. Second coat is applied perpendicular direction. Ensures coverage is one direction, ensures coverage in the other direction. This helps achieve more uniform and continuous coverage and reduces the possibility of missed areas. Next is the waterproofing upturn. Typical upturn 300 mm minimum. This is the upturn. In the presentation, a typical toilet or bathroom upturn is shown as approximately 300 mm minimum. But the actual project requirement should always cover. Particular attention is required at corners and wall floor junctions to maintain continuous waterproofing. Okay. Coming to protection of waterproofing. Once the waterproofing coating has been completed, the must protect it. Waterproofing can easily be damaged by subsequent construction activities. Horizontal protection may be provided using the specified protective screed or protection plaster or concrete. Typically shown here as 50 to 75 mm subject to project specifications. Okay. Vertical projection may be provided using protective plaster, typically 15 to 20 mm, again as specified. Okay. Now comes to the final static water bonding test. After completion of the protection plaster or anything else, water is maintained at the full available depth for 72 hours as per the methodology presented. The underside of the slab and the surrounding walls are inspected for leakage or dampness. Please remember, the underside of the slab and the surrounding walls are inspected for leakage or dampness. Only after satisfactory inspection should the area be released for the time works. That means next activity. Okay. Material selection for the quick comparison. Cementitious flexible PU materials, acrylic systems. Addition to concrete, cementitious is excellent. PU, good and excellent. Acrylic also be good. Flexibility, moderate to high. Cementitious systems. PU, high, very high. Acrylic, moderate. Dam substrate tolerance, that means moisture. Generally good system dependent. Usually more restrictive, sensitive. This is the product dependent. Application, this is the brush or roller, anything else. This is a brush roller spraying machines. This is also brush roller. Toilet application, that is the rating, 5-star rating, 4-star. This is the 3-star. Ease of application, high, moderate, high. Cost, moderate, higher, moderate. This is economically high. System is economically high. PU or polyurethane or polyurea. Tile compatibility, generally good with approved systems, must be verified. Must be verified. This is the common mistakes. Skipping pre-pawning, poor surface preparation, incorrect mixing ratios, adding extra water, wrong substrate moisture condition, insufficient coating thickness. That means less than the specified thickness compromises protection. Missed piped penetrations, unsealed penetrations are major leakage points. Poor coving, waterproofing damaged by other trades. This is the very, very, very big miscommunication between the other traders. Please ensure before the coating, before the waterproofing works, all trades or works are completed at this location. That means mechanical, electrical, plumbing, MEP related works. Okay, no final bonding test. Poor documentation. Incomplete records lead to ownership and warranty issues. Plan it right, do it right, test it right, document it right. Remember, follow mother statement. Quality today, protection for life. Okay. QAQC inspection checklist. Before waterproofing, during waterproofing, after waterproofing. These are all covers with before waterproofing. Surface preparation, bore packing, crack treatment, joint treatment, coving, initial bonding accepted. During waterproofing, SSD condition, concrete mixing, application rate, coat direction, recoat interval. This is also be very important, recoat interval as per the TDS. Thickness, that means 1 mm or 1.2 mm, 1.5 mm, that is the project requirement. Upturns, that is also be project specifications or project requirement. This is also covering on the waterproofing during water. After waterproofing, protection screed or protection plaster, final bonding, leakage inspection, documentation, release for tiling. Note, all checks to be recorded with the photos and maintained as part of QAQC documentation. Please remember. Let's look at the practical impact of quality control. Imagine two identical toilets. One toilet A, the team skips pre-ponding, directly applies waterproofing coating, completes screed and tiles, and hands over the apartment. The mother's 3 months later leakage. In toilet B, the team follows the sequence. Initial ponding detects a defect, the defect is rectified, ponding is repeated, waterproofing is applied, protection is provided, final 72 hours ponding also be completed. Then the toilet is released for tiling. This is the difference between finishing the activity and controlling the quality of the activity. Don't cover the defect, rectify the defect. Okay, guys. Hidden today, leakage tomorrow. Rectify today, protection forever. Thank you for watching this quality icons presentation on toilets waterproofing systems. If you found this video useful for your QAQC work, site execution and construction quality awareness, please like this video, share it with your site team and subscribe to the Quality Icons channel. Your support motivates us to create more practical videos on construction quality, QAQC inspection procedures, testing material and site workmanship. And remember our quality icons principle. Inspect before you cover. Find the defect, rectify the defect, test it, document it. Thank you and see you in the next quality icons video.